So in this video, we're going to talk about double number line diagrams. I use a hashtag instead of number because it just didn't feel like writing it out. So a double number line graph, or a double line graph, are best used when your units are not the same in your ratio. For instance, if we're comparing 10 meters and 4 seconds. Meters and seconds are obviously different units, so we would want to use a double number line graph because we don't want to put two different types of units on the same thing. So on a double number line diagram, if the top and bottom numbers are in the same ratio, then they are located the same distance from zero on their number lines. Once we represent our 10 and the 4, as I said in our example, we have 10 meters and 4 seconds, then we'll use multiplication to find equivalent ratios. And remember, an equivalent ratio is just going to be something that, it's like an equivalent fraction, where if we kept reducing it, it would go back to what we started with. So I'm going to draw my two number lines, which is something we've been dealing with since day one. And I'm going to call my top one meters and my bottom 1 seconds. And I'm going to start at 0. I'm not going less than 0, at least not in this circumstance. And I'm going to mark my 10 and my 4. Okay, so I've got my 10 meters in 4 seconds. And notice that 10 and 4 are equidistant from 0. Because this is my ratio, 10 to 4. Alright, so now I can use multiplication or division, if I'm going to go smaller, to find equivalent ratios. So if I multiply my 10 by 2, I get 20. If I multiply 4 by 2, I get 8. So 20 over 8 is an equivalent ratio to 10 to 4. If I divide 10 by 2, I get 5. If I divide 4 by 2, I get 2. So 5 over 2 is also an equivalent ratio to 10 to 4. So this is how I use multiplication. I can add up here. Or division to find an equivalent ratio. So this is an example of a double number line diagram, and we can use this to solve problems. Okay, so let's look at some more. So here I have my same double number line diagram, but you'll notice this time it's missing some numbers. So I've got my 10 and 4, got my 5 and 2, I've got my zeros. So I have some spaces here, I have some spaces here. So if I have 5 and 2, knowing this is how long it would take, knowing that I've got 5 to 2, how long would it take to go 15 meters? So there's a few ways you can go with this. So if I know 5 to 2, then let's go back and figure out the unit rate. So my unit rate would be what? Well, remember, to find one unit rate, we take it and we set up our proportion and we divide. So the unit rate would be 5 over 2. When we divide that, we find out that it's 2.5 over 1. Because remember, when you're solving for a unit rate, you want to find out how much one unit is. So that means that up here where my question mark is, I would put 2.5 to 1. Okay, so the unit rate would be 2.5. So then, how can I find out how long it would take to go 15 meters? Well, I can take 15 and divide by 2.5, and I'm going to learn that this should be 6. So I would find out that 15 meters would take 6 seconds. Okay, so again, what I did was I found out that the unit here is going to be for every 1 second we go 2.5 meters. So once I knew my unit rate, I was able to take the 15 and divide by my unit rate, and I found out that it would take 6 seconds to go 15 meters. So in doing this double line graph, I've kind of applied what I've learned about ratios and about units and put it to work. Okay, so let's look at one more example. Do a word problem. So driving at a constant speed, you drove 14 miles in 20 minutes. On a double number line, it's not a hashtag here, it's a number sign, show different distances and times that would give you the same speed. So if we drove 14 miles, and I've labeled the top line distance and the bottom line time, 14 miles in 20 minutes. We want to just show different distances. So we're not even having to solve a whole lot here. We're just showing different distances. If this were a standardized test and this were a question, the question could very well be, which of the following numbers are not numbers that could be on this number line? So if we went 14 miles in 20 minutes, we could also say that we went 7 miles in 10 minutes. We could also come up here and say that we went 21 miles, and it would be in 30 minutes. Or we could say that we went 28 miles. And look, we're going by increments of 10, so this would be in 40 minutes. This was 7 times 1, times 2, times 3, times 4. Again, times 1, times 2, times 3, times 4. So, when you're working with double number lines, the key is knowing A, what your ratio is, what your equivalency is, what you're multiplying by, and being able to determine your unit rate.